most important technological advance of the 20th century. It has given rise to the information age. It has caused the speed of new discoveries to increase by an unprecedented amount. It has allowed people all over the world to find a common ground and has provided a platform for worldwide discussion and even trade. And to think, it was all caused by a few Russians launching a glorified metal basketball into space.
In 1957, Russia launched a Sputnik satellite into orbit. America, deep into the Cold War, panicked and became very nervous that Russia had superior technology. In response, President Eisenhower decided that America should retake the lead and immediately began providing large research grants for American scientists. So much so that Defense Secretary McElroy used these newfound funds to form ARPA, the Advanced Research Projects Agency, in 1958 to research new and innovative ideas. As a result of the rise of ARPA and Eisenhower's encouragement for research, R&D funds rose from $5 to $13 billion between 1959 and 1964.
Originally, computers used batch processing, so time sharing was a large problem. In 1962, Joseph Licklider, affectionately known as Lick, recognized this problem and was chosen to direct a project that allowed one computer to reach out and use the resources of another machine. The SAGE, the Semi-Automatic Ground Environment Project, was designed to detect Russian missiles, but also allowed the user to interact with remote machines via telephone lines and also get answers in real time, laying the foundations for the idea of the Internet.
Licklider saw this as the future of computing. Bob Taylor used this idea to get large amounts of additional funding and then used his knack for picking talent to select Larry Roberts, an amazing problem solver that also agreed with the potentials for time sharing.
About the same time, Paul Barron and Donald Davies were working on the same networking problems. Their ideas, first, make the network distributed so a single missile hit won't destroy the entire network. They proved the importance of this by showing that AT&T, the telecommunications giant at the time, would fail given a Soviet attack. The solution was also to make a system of switches and pass blocks of information between these systems, which they coined to be known as packets.
Though this posed many problems, Wes Clark entered and gave a new design for the network, where there are subnets and hosts that do as little as possible. This was accepted as a solution, and the next step was to develop the intermediate controllers to deal with the hosts, which came in the form of the IMP, or Interface Message Processor.
Bolt, Beranek, and Newman got the contract to build the IMP. They brought in super engineer and manager Frank Hart, who then proceeded to sign programming experts Will Crowther and Dave Walter. They decided to build the IMP to be completely transparent and so that host responsibilities and network responsibilities could be separated.
Each site would have its own IMP, and Honeywell actually created the first hardware for the IMP, doing a terrible job, which led young Ben Barker to spend almost all of his time working with the wiring and hardware. In the summer of 1968, grad students from the first 4 IMP host sites met and made the first Request for Comments, or RFC, about the protocols that would run this network. This became the Network Working Group, or NWG. In late 1969, the first 4 IMPs were successfully delivered to their sites and installed, and in 1970, a cross-country network link was established to BBN. This allowed remote maintenance and diagnostics to be performed. The next big innovation was a terminal IMP, or TIP, which allowed a single terminal to connect directly to many lines and was more or less the first router.
Over time, congestion control routines were improved, as were network control and diagnostics. In 1971, the NWG produced the Network Control Protocol, or NCP, the first real protocol given to govern the transfer of data on the network. And in 1972, FTP was initiated as RFC 354. As the October 1972 International Conference on Computer Communications in DC approached, there were 29 nodes on what was now being called the ARPANET. The ICCC gathered vendors and companies to show their products interacting with the network. The conference was a huge success, and the demonstration showed that packet switching based networks were exciting technologies that held a vast array of applications.
As the network grew, resource sharing, the initial point of the ARPANET, was not as widely used as email, and email adoption caused a huge increase in network traffic. This forced growth on the logistics side, and email caused the growth of the ARPANET as the Louisiana Purchase caused the growth of the United States. The first email was sent in 1972 by Ray Tomlinson at BBN, and at the time, 3/4 of network traffic was email. Today, 1 to 1.5% is email, 66% of which is spam. In 1975, Message Group was founded to discuss the message service, which was really the first mailing list. Email started to become dangerous to the future of the postal service, and in 1980, the net had become an important social medium for discussion and interaction that was completely independent of the supporting technologies.
In the early 1970s, SatNet, a network that used satellite communication instead of hardlines, was established, and in 1972, the International Network Working Group was founded to work on the concatenated network, also known as CateNet, that was to integrate the various types of existing networks. In 1973, the first Ethernet was made and named, which is important as it later allowed small networks to collectively gain access to larger networks. The CERF-CON paper of 1974 defined TCP and gateways for the first time, while in 1975, the Defense Communications Agency took over networking management for the DARPA, who now concentrate on protocols. In 1978, TCP became the two protocols that we know today as TCP/IP.
In the 80s, CSNet was established for computer science programs nationwide. Usenet and others were to follow, all of which used TCP/IP, and it was starting to be collectively called the Internet. Foreign countries began connecting their networks to the Internet, and NSFNet was the backbone academic network provided by the National Science Foundation. LANs became popular and easy to set up, and Simple Mail Transfer Protocol was invented to better handle email. DNS was made to better categorize and name computers who couldn't all be named Frodo as the computer operators wished.
By the end of 1989, the ARPANET had been completely decommissioned, and all the sites switched to other networks. NSFNet and the regional networks became the backbone of the Internet. www and HTTP were to come in the early 90s, which along with wireless technology, more or less leave the Internet where it currently is today, in all of its majesty.